Here we are to demo the laser Linewidth analyzer. Optilab has been spent like over almost a year developing this thing. This is our first fully assembled unit. It's in a 3U rack mount housing with all the optics and the electronics integrated together with our software development as a whole integrated solution for laser Linewidth measurement. Here we have a few different lasers with different Linewidth. This one with like a wider Linewidth, and this one with a narrow Linewidth, like down to like a few tens of kilohertz. I'll leave the rest part for Kevin.
Okay.
To show us how to use this instrument and what kind of result we can get.
Okay. So just to add one point, this unit is our newly developed no noise laser diode controller. Because with most other controllers, you'll get some more electrical noise that will broaden the Linewidth. So this is our fully developed controller especially for narrow Linewidth laser measurement. Okay, so here you can see we have a narrow Linewidth laser, which only has a few of tens of kilohertz Linewidth mount on top of this, and you have an on-off switch here to turn the laser on, and with this knob you can control the supply current, the driving current for the diode, and also we have a small LED screen here to show the basic information of the diode, such as TEC setting and the output power. So very simple to use this laser Linewidth analyzer. You just input the laser output into the front panel laser input reticle, and you turn on the power, of course, of the unit, and every other electronic stuff will be turned on automatically inside. And here you just need a RF cable to connect these two ports together for the use of software. Okay, so you got some information here also on the LED screen, such as the input power of the laser, and there's a clock frequency setting, which is used to for the Linewidth measurement. Let's see. Yeah, here you can see some basic information of the unit, including the serial number, software version, something like that. Yeah, pretty simple. So if you turn off the laser and just turn on the software, this is just showing the noise level, and this peak corresponds to the clock signal, which is built in the unit. And if you turn the laser back on, and you can see like a kind of electrical spectrum, but it's actually converted from optical spectrum of the laser, which is shown here. And here we already did some average. If you want to see the raw data, that's this. Let's see. Okay. Typically, you want to enable the average function, since there's some kind of environmental noise that will make the curve fluctuate. The good thing one of the best thing included in our software is the auto fit function, so you can fit the curve to get a theoretical estimation of the Linewidth value. So here we are using the Lorentzian function to fit the curve. You have several ranges to set in terms of the actual line width. Like for this one, if you have an even narrower line width laser, you should enable this range. And if you have a wide, a broad line width laser, you should use this range. So it looks that the range 2 is perfect for this, and here you can see our calculation, our estimation of the line width value in the unit of hertz. So right now it measured about 70, 80 kilohertz line width of all of this laser. Alright, so if I change to let me disable this. Change to a laser with a broader line width. The only thing you need to do is just to insert the laser output in and turn the laser back on. Okay. So now you can see the signal is pretty much like a straight line, flat line here. That's obvious because the line width is very large. So you need to set a different span here, a larger span. Let's disable the average right now. Okay. You can say even larger. Alright, that looks better. And of course, with this kind of broad spectrum, you want to change the auto fitting range. So it's almost there. And if you do 4, that's kind of the best choice to fit this line width data. So here you can see that the line width of this laser is almost 4 megahertz. Right. So.
Okay, we should talk about some software development.
Yeah.
Come on, go to
Everybody's. I think Karen's gonna talk a lot about that. And basically, I design all the software. At the left part, you can change every default setting of these devices. And at the right hand is just a trace. There's some several functions that you can adjust to the curve, and there's auto fitting function that you can do a math algorithm to fit the curve. You can also export the data, the raw data from what you get from the devices. At the same time, you can also save as a PDF or print the lab report at right here.
So you want to talk about like what kind of code do you use? Is it library mostly, or do you do some other coding?
The coding part, I use Qt, and it's based on the 32 bytes, and it's just only for the interface, but we also import a lot of algorithm inside to enhance it works well, and include because it's a large data, so we're trying to figure out a way doing an algorithm to make it quicker and can allow it to store a large data.
What language? C, C++?
It's based on C++, and it also has some like external library import in the Qt.
So how long the coding part?
The coding is like 5,000 lines, and it takes me about 2 weeks to finish it, and about like 2 weeks to improve it.
You know, because what do you think? How long does it take for us to take matching for one laser line width in a production environment? How long does it take?
Production environment.
Say somebody do this, you know, like
All day long, I think within 1 minute. If it's really quick enough to switch the laser.
Yeah, I think that's the, you know, that's the benefit of it, because this line width measurement is very time consuming, and this takes the errors away, you know, because the algorithm basically calculates it. All you have to do is really to put a laser in, turn it on, and adjust a couple of ranges, you know. And
that's right.
so for production tool, you know, if you could do like 50 an hour, you know, then the value is huge, you know, because if you don't know laser line width, in the future of coherent communication, right? You know, like you need to know how well your laser coherent length is. You know, so this is very big. All right.